Today's problem is exactly one swap. So the problem statement is given a string S, return the number of distinct strings that can be obtained by exactly one swap of two different indices I less than j. So for the first example, geek. So we have to swap different indices for this example. We can swap g and e. We can swap this g and this e. We can swap this g and this k. And same way we can swap this e and this e. We can swap this e and this k. And we can swap this e and k to create different distinct strings. So like this we need to find how many distinct strings can be possible if we do that. Now in this particular example all the characters are same, so there will be only one unique string or distinct string, because if we swap this and a, it will still gives us a. If we swap these two a's, it will still give us a, etc. So let's consider the first example, geek. So here the possibilities are we can swap this g and this e, so that it will be e, g, e, k. Then we can swap this g and this e, so that it will be e, e, g, k. And we can also swap this g and this k, so that it will be k, e, e, g. So that's all the strings, like all the strings that we can form if we swap g to any of these positions. Now we can repeat the process for this e as well. So if we swap this e and this e, it will give us geek. Now if we swap this e and this k, it will give us g, k, e, e. So these are the strings that are generated. If we swap this e with all the other remaining characters. So one thing to make sure is I must be less than j. So now the next thing is we can swap this e with this k, so that it will give us g, e, k, e. So these are all the different strings that we can create after swapping. Now suppose, let's say we have different, like completely different. Here e repeats twice, so it will give us only one, like the g, e, k. It have a repeat, so it will give us only one string in particular case. Like so, let me have a, b, c, d. In this particular case, all the characters are having a count of 1. So the different strings that we can form are b, a, c, d, or c, b, a, d, or d, b, c, a. We have finished with a. Now for b, it will be a, c, b, and d, and b and d. So it will be a, d, c, b. Now in this particular case we have d. So sorry, now we need to go for the c. So we can swap the c and d, which will give us a, b, d, c. So if all the 4 characters are distinct, then there will be 4 into 4 minus 1 by 2 number of distinct characters. That is 4 into 3 is 12, 12 by 2, 6 different characters if all the strings are distinct. And if all the strings are same, like if any of these swap will still give us a, and that will just contribute as 1. So the brute force way will be to try out all the indexes. Like if we can fix a at first, then we can go and swap all the b, c, d's. create the string and store into some hash set. Then we can try to explore this B and swap it with C and D and create the strings and store it in the hash set. Same way we can create all the substrings for this C and swap this, like swap with C and D and create the new string and store into the hash set. And the final hash set size will be the number of distinct string that we can create. So that will contribute to a big of n square into, we will be creating each time a n strings, like n size new strings after the swapping. So it will be a big of n cube time complexity, and we are also making use of an extra hash set which will contribute a big of n time complexity. So we are making use of additional space, and it will create problems. So one thing is sure, like if all the characters are distinct, then n into n minus 1 by 2 is the answer that we are looking for, wherein is the length of the string. The case comes when we have any duplicates. So A, B, C, for example, or let's say B. So in this case, A appears twice, B appears once. So we can swap AA and it will create us AAB. Now we can swap A and B, it will give us B, A, A. Now we can't do anything with this A. Now we can swap this A and B and it will give us A, B, A. So whenever we have the characters repeating like more than once, then that will contribute only 1 to our answer. Okay, suppose like it was A, B. Let's take one more example. A, B. So at first we can swap these two A's and we can form AA, AB. Now we can swap these two AA, but it will still give us an answer AAB. So we can only create one unique string with those combinations. Now we can swap this A and B and it will give us B, A, which is a new string. Now we can swap these two strings, and if we swap these two strings, it will still give us AAAB. This is already, we have already seen that, so that won't contribute to our answer. And we can swap this A and B, which will give us A, B, A, B. Now the left one is these two. We can swap them and give A, B, A. So in this particular example, our A has 3 count and B has 1. So if we are standing at a particular index I, so this example itself, suppose we are standing at this position and we know A has already appeared once. So these many characters, like if we are at an index I, then I minus whatever the frequency of A characters have appeared before. So that many unique strings that we can create. So we can add answer plus equal to whatever be the index minus the frequency of that character. And this will give us how many unique or distinct strings that we can create. And we also need to track if any of the characters have any count greater than 1. That means it is repeating. So it will only contribute to one answer, like it will only contribute one answer. So at the final, when we are returning, we just need to add plus 1 if there is any character that are appearing more than once. So that can be solved in big of n time complexity, and we are not making use of any like we are not creating new strings, or we are not storing it into any hash set, and that space complexity will be big of 1. So let's try the approach. So if S is equal to null, or s dot length is equal to 0, we can say there is no string, so we can just return 0. There are no distinct strings. Now we can store the length. We need a frequency array of size 26. So here there will be like I'm considering like there will be only lowercase, or I just need to shift this to 256. So there is only lowercase characters in this particular case, and we need to count distinct strings which is equal to 0, and we can have like value repeat, which can be 0, meaning like no characters are repeated initially. Now we can go through each of the characters that are present at the length. Now if we are standing at the first A, there are I minus, that is 0 minus count of A, or the frequency of A. So frequency of A is initially 0. So there are 0. So we need to have count distinct strings plus equal to index minus the count that we have seen so far, because that many characters are present before. Now we need to increase the frequency. Now we need to see if the frequency of the correct character goes beyond 1. If that's the case, like we have repeating characters, we can flip this value repeat to 1, and finally we can like return whatever the count distinct strings, plus if there is any value repeat, then that will give us only a one unique or one distinct string. So we can add value repeat to the answer. Now we can compile, and there is, you can see, okay, let me have char ch is equal to s dot char of index. Let me run it once more. It's accepted. Let's submit the solution. And this is accepted. So here the time complexity is big of n, where n is the number of, or that length of the string, and we are not making use of any extra space complexity other than the big of 26 frequency array.